It is finally time to learn how to parse these expressions that we have been ignoring. Expressions are probably the most challenging part of writing a parser, but I think that they're the most fun as well. One of the reasons expressions are harder to parse is because of something called operator precedence. Remember, please excuse my dear Aunt Sally? The order of operations is actually just another term for operator precedence. Take a look at this expression. If we were to represent this in a tree, it could look something like this. We would have an expression node that performs addition, and the left child could be an expression that just produces the value of 5. The right child of the plus expression is just another expression node, except for one that is a multiplication type. The multiplication, which has to come first, would be located deeper on our tree. This isn't particularly easy to do, especially using the recursive descent pattern that we have used for these statements. Operator precedence is also influenced by using parentheses for a given operation. We could rewrite the previous equation like this. And this means that the addition would need to take place first. The addition got a boost in precedence. Our parser needs to understand these precedence rules between different operators. In our language, we will have a couple different types of operators. The following are called infix operators, which live between two expressions or values. These are your typical add, divide, multiply, and subtract. We also have these comparison operators, is equal to, is not equal to, less than, and greater than. And then we will have the prefix operators, which come before an expression or value, like -5 or the not expression. And we will have to mix and intermingle all of these according to our rules alongside the wildcards that are the parentheses. Those are our operators. And now if we think about all of our expressions and their different flavors, expressions can make up functions. Functions can be bound to variables. We have expressions to call said functions. And because personally I'm a big fan of Kotlin, even our if statements can produce values. So they are also expressions. And looking at all of this together may induce some panic. Like I said before, for operator precedence parsing, we don't really want to use our method of recursive descent parsing based on grammar rules. Instead, programmers have had to get really creative and really ingenious. For example, the guys that wrote the Fortran compiler came up with an awesome trick. Given an expression that looks like this, the first thing that they do is add 3 open parentheses to the right. Then, anytime they encounter a plus, they replace it with 3 closed parens, the plus sign, and 3 open parens. Every multiplication sign gets replaced by 2 closed parens, the multiplication sign, and 2 open parens. Every minus sign gets treated the same as the addition. 3 closed parens, the minus sign, 3 open parens. And at the end of the expression, they add 3 more closing parens. And while this looks like a hot mess, this actually creates a parentheses matching that always works. A relatively simple parser could be created to work through these expressions by matching these parentheses. We are going to use something that is called Pratt parsing. The trick with Pratt parsing is that instead of associating functions with grammar rules, he instead associated them with single token types. These token types could then be parsed depending if it was in a prefix or infix position. Remember that prefix comes before a value, infix comes between 2 values. All of this is going to take a couple of videos to build, and I want to keep these in about 5-minute chunks. So in the next video, without further ado, we are going to start preparing our abstract syntax tree package to handle our expressions. See you there.